First, let me remind you of the circle parameterization in 2 dimensions. We did this in a previous chapter. If we've got the x and y coordinate system and a circle with a radius of 3 centered at the origin, the parameterization could be something like this. 3 cosine theta, 3 sine theta. Now there are many other variations. For example, we could have the sine and the cosine switched. Which would give us the same circle, it would just be drawn in a different pattern. We could also have negatives on any of these in any order whatsoever. For example, the first one could be a negative 3 cosine theta. We could also have a negative on the second one. And I won't continue writing these down. You get the idea. There could be negatives on both of those. You could also have them swapped, the sine and the cosine that is, with negatives on either or both. So I didn't count how many variations that is. But notice in our problem we're told something about the coordinates that we want. However, this is 2 dimensions. Let's change that to 3 dimensions. You notice in 3 dimensions we want the plane that is parallel to the XZ plane. And so all I'm going to do is come over here on my picture and call this X and Z. Which means if this first component is X and this second one is Z, all of this stuff is still valid. But now in 3 dimensions we want the circle that is parallel to the XZ plane. So all of the circles are going to have the same y coordinate, which is -5. So our parameterization for a circle centered at the origin in 3 dimensions would need an x component, y component, and z component. Now again, we're told that we want the x component to contain a positive cosine. So we're going to be using this parameterization. 3 cosine theta, 3 sine theta. Now again, this just means that the y can be any constant. The one we want is the one mentioned in the problem, -5. Now the only issue then is changing the center to be -3, -5, and 4. So back in our 2-dimension equivalent, if we had a circle centered somewhere besides the origin, then this would be some number, we'll call it h, plus 3 cosine, and this one would be some number, we'll call it k, plus 3 sine. And so all we're going to do is just add our numbers. So the x coordinate we want to be -3. So right here on the x coordinate we'll put a -3. And the z coordinate needs to be 4. So right here on the z coordinate we'll put 4. So there's our parameterization. Now we want to write these in terms of t. I've been saying everything in terms of thetas like we did back in a previous chapter. So the x component would be -3 plus 3 cosine theta, t, sorry about that. And the y component would be -5. The z component would be a 4 plus 3 sine t.